Hi, good afternoon, everyone, and welcome to the webinar How to Design and Engineer Mass Timber and Hybrid Multi-Story Structures. Maybe I need to say also good morning and good evening, because we have people from all over the world today. So we have 54 countries connected. So it's absolutely amazing. We have people, of course, from UK joining us, Ireland, but also just to mention some countries: Hong Kong, Chile, Denmark, Austria, Italy, Australia, Canada, India, Mexico, Colombia, Brazil, Portugal, Spain, Singapore, Kenya, Jordan, Hungary, Finland, and New Zealand. And this not all. So it's very pleasure to be here today. Okay, this webinar is part of the Roto School on Tour, which unfortunately this year, due to the COVID situation, we have not been able to perform live as usual, but we are still working for the next event in 2022 in springtime. We have already a date for the event in London. Will be one day. The venue is at the in London at the Institution of Structural Engineering. Then we will be in Dublin, in Ireland, at the university, and finally in Reykjavik, in Iceland. Every country, more or less, in Europe will have a Roto School next year, live, so one day seminar. In the meantime, we are waiting all the participants here. Basically, I want to say thanks to the Institution of Structural Engineer that help us to realize this webinar. And I want to say thanks also to the speakers that are with me today. So from Peter Theobald, Luca Pozza, and Matteo Andreottola. I will introduce them before each presentation. Really brief introduction about me. My name is Stefano Muscoloni. I am the General Manager for Rothoblaas in UK, Ireland and Iceland. I have been working in UK for 5 years now. My background is construction engineering, and I am specialized in energy saving of buildings. Day-to-day webinar will focus on, as you know, on engineering and design of multi-story building in mass timber. So we will speak a lot about cross-laminating timber, glulam, LVL, but also hybrid solution. So hybrid multi-story buildings. So to understand the connection for a multi-story building with the mass timber together with the steel structure or concrete structure. The interaction of the different building materials will be analyzed to understand the benefit, but also the potential of in a multi-story application, multi-story structure. Unfortunately, today the time available is only 1 hour, so it's absolutely not enough to cover and go deep in all the topics related. So we will touch the main topics from the structure, fire, durability, vibration, acoustic, but of course it's impossible to go deeply in everything. I don't want to waste time because we don't have time, so I want to go right to the point. Last things, at the end of the presentation, we will have we will answer your questions. Probably only a few. Again, the time is not a lot, but we will reply to all your questions by email in the next days. So let me start to introduce Peter Theobald. Peter Theobald is my colleague. He's managing the southwest of England and Wales for Rothoblaas. Peter joined us in 2019 because he wanted to develop his passion for timber and construction from a practical carpentry background. He holds City and Guilds Level 2 qualification in both joinery and site carpentry. as well as H&C in construction and built environment. Peter will provide a short presentation about who we are, where we are, what we are doing for the people who don't know what Rothoblaas is doing. So, Peter.
Hi there, everybody. I've been charged with trying to condense everything that Rothoblaas does into about 5 minutes. So bear with me. I'll have to be quick.
Yes.
Welcome to our solutions. And also, I'd love to say welcome to our webinar and welcome to our 30-year anniversary. 30 years for Rothoblaas has looked like this, starting in 1991 with just one country with Salesforce. Today, we're in more than 46 countries, and we have over 22 subsidiaries, 23 subsidiaries now. So you can see the growth. We've grown alongside timber construction and mass timber, particularly in the Alpine region in the north of Italy, where we're from. So as you can see by the amount of people from around the world who are here today, we cover the globe. Just you can see here is every dark grey area is where we have sales agents and technical representatives ready to help you and help you realise your projects. The UK subsidiary opened last year, and that's where me and Stefano work for Rothoblaas. What we do, pretty much a lot of things. We have the Rotho School events, which you can sort of attend in person, hopefully someday. We also do a lot of technical documentation, product catalogs, a lot of predetermined static and characteristic values for you as designers. All our declarations of performance and our BIM and CAD libraries are all available online. We also provide tools for designing, such as our calculation software. And also through our Salesforce and through our technical consultants, we can help you get hold of our qualified product engineers. So no matter what you're looking at, we'll help you find a solution. One of the favorite things I heard somebody say is this statement here, that Rothoblaas provides you with everything you need to design and build with using timber, apart from the timber. Now you can choose that yourself and source it locally, because that's the most sustainable way of doing it. But in that sort of mindset, we offer a lot of solutions through fastening, air tightness and waterproofing, soundproofing, full protection, and also any tools and machinery you may need to build your project. Being that you guys are predominantly from the engineering side, I think that you'd be more interested in our solutions in terms of plates and connectors. And you can see our lovely catalogue here on the left. In that, you will find a full range of connection solutions and a lot of calculations and tables and fastening options, all determined to make your life easier as a designer. You can download this for free and use it as a PDF, or alternatively, please get in contact with our agents. There's nothing more we love than being able to visit and drop off our stunning catalogue for you. It's a really good one. It's very thick as well, 500 pages. Also in there, you will find a lot of our solutions that we're going to discuss later today to do with multi-rise and hybrid connections. So please do take the time to take a look. Here's some sort of the kind of high level products that we are very proud of to develop and innovate. The spider and pillar for multi-rise construction here on the left. Also elements such as the lock, which can be used for all sorts of innovative ways of building. Something that I'm very passionate about and really enjoy is the screws and connectors catalogue. I know it seems quite sad, but I just love the way that the screws work and that we have a solution pretty much for everything, whether it's carpentry, structural, outdoors with cladding materials, or even for timber to metal applications. And we have a full range. It's a great catalogue, and one of the things that's worth noting is we have spent a lot of time developing our main products of screws with an ETA certification, so that we know the values of our screws in all sorts of materials to help you design and build with these timber materials. So we have all the values for LVL, we have values for glulam and standard softwoods. We also have values for CLT in all sorts of iterations. And also in our ETA, we have a value for calculating for when screws are in parallel to the grain, which can be useful, particularly with CLT design. Also, as well as being able to screw timber together, we give you everything you need to ensure its durability during the life of a building. So in our tape sealants and membranes range, you will find connections to the ground and how to protect timber elements. Also, you will find roof and ventilation options and a full range of barriers, stops, membranes. And in this catalogue, you'll find solutions also will help you design and look after structures during fire. Something that's really lovely that we've started to work on is we have more and more components that are certified components for passive house. So you can see here on the left-hand side, the Klima control, which is an SD variable membrane, but also we have certification for all sorts of countries and national standards across the world. So no matter what you're designing for or what the climate is, we have a solution. And also in this lovely new catalogue for the membranes, we have life cycle assessments and EPDs. Also, part of our range, we do the acoustics. This is very useful when considering the structural integrity of the building and also how to design for the structural elements and how they'll behave acoustically. And as part of that, particularly with CLT, we funded and did a huge research on flanking sounds in mass timber and CLT junctions. So we have a lot of knowledge and a lot of values for how products like our Xylophone here, the coloured resilient profile, behaves in structural connections and how that can help you design for acoustic requirements. Also, for the carpenter and the installer, we have a lot of products in the tools catalogue, which are very, very useful and some very bespoke and needed for mass timber building. And also, just to add a little bit of extra on the end, we have our full protection and safety range. We've taken all our years of engineering know-how and put that into a comprehensive safety range and can help engineers and safety professionals connect to timber. And something that's lovely that we're really proud of is our headquarters is expanding, and we have decided to install and create perhaps the largest timber warehouse and automated warehouse in Europe, all made from locally processed timber from our region. And we are looking forward to it being completed later this year. Here's how it should look when it's all finished. I hope that that has kind of wrapped everything into one place in a very short period of time. And I'd like to say thank you for your attention, guys.
Thanks, Peter. Thanks for the presentation. Let's go straight to Luca Pozza presentation now. We are in the best part of the webinar now with Luca. It's a pleasure to have Luca here. Luca Pozza is assistant professor at the University of Bologna in Italy. In 2008, he graduated with full marks at the University of Padua and is working since 2014 as professor at the University of Bologna, exploiting, teaching, and doing research activities. His research activity cover different themes in the field of timber engineering. He works as structural engineer and carries out technical consultancy activities in the design of timber structure for many Italian and foreign companies. So thanks, Luca, to be here with us today.
Okay, I share my screen. Good afternoon, everybody. These are the outlines of my presentation. So we start giving you some information about mid-rise, high-rise, and tall timber building. Then we will focus on mass timber construction and specifically on CLT building, post and beam buildings, or other technology derived from the first two that are post and beam panel system or post and platform system. Then I give you a brief introduction about hybrid technology, and specifically I've chosen two different types of technology that for me are really interesting. The first one are the post-tension and the timber system, while the second one are timber concrete composite system. And at the end, I will give you some information, some guidelines about the design of a robust mass timber or hybrid structure, providing some general principles and design criteria, and sharing with you some structural details. So in this first slide, I make this picture with the aim to define the interaction between different material we can use to realize a timber structure. So, of course, we have engineered wood products such as glulam, CLT, LVL that can be assembled together by means of connection and fastening systems such as screw, brackets, nail, and special connection system, as you've seen in the previous presentation. So, in this way, we obtain standard timber structure, such as a timber frame or massive timber building. Then we can use other materials, such as concrete or steel, realizing hybrid construction, and specifically timber concrete composite system or hybrid steel to timber system. For every type of building, the issue we have to discuss about are which are the load-bearing capacity of this system against the vertical and lateral actions. Then the fire resistance is another important issue, the durability, and finally the robustness. So in this slide, I've used some picture to explain the difference between three types of building: mid-rise building that are typically realized using light material and light technology, such as light frame building up to 6-story. Then we have the most widespread nowadays technology or timber system, which is a mass timber system typically used to realize high-rise building. And finally, we have tall buildings. In this case, we have superstructure that can be realized only employing hybrid solution. So each of these three types of building typology have to be designed using different analysis approach. Of course, for mid-rise building, we can use standard calculation rules. On the contrary, when we design high-rise building, we have to use special analysis, special design approach, and for tall building, special investigation, special design criteria, special structural details, special solutions are also necessary. So in this picture, as an example, I've reported some structural analysis on a 12-story CLT building that is characterized by high lateral deformability under seismic actions. So in this case, the numerical analysis is necessary to define the lateral deformability of the system and the base action of the shear wall. Similarly, for this type of structure, special analyses are necessary. For example, the wind-induced vibration analysis that allow to define the effect of special environmental action on the structure and allow to make some special design choices, such as the realization of some concrete floors in the upper level of the building. So in this slide, I've tried to summarize the concept I've just tell you. First of all, the maximum height of the building depends on design codes or design limitation. These design limitations are generally due to the confidence that each country have in that technology. It is also governed by the expertise of each practitioners or the state of art of this special on that technology. Then the height of a building can be defined also by the external action, especially wind or earthquake. But the most limitative issue is the strength and the stiffness of the material, especially timber or connection. Timber generally for the problem of load-bearing capacity, while connection for a problem due to the stiffness. In any case, both for mid-rise and high-rise, the robustness issue have to be properly investigated. So now we start analyzing mass timber construction. So this type of construction are realized using engineered wood products such as CLT, glulam, LVL, and so on. They are typically manufactured off-site and are realized using high-performance material. So material characterized by a high strength to weight ratio. Of course, this type of structure are environmentally friendly, but show also some limitation, such as the acoustic insulation problem due to durability, and finally the fire resistance, since wood is a combustible material. So in this slide, I've tried to combine the two basic material of mass timber construction, the CLT panel and the glulam or LVL elements. So one-dimensional elements and two-dimensional elements. So using only CLT panel, we can realize CLT buildings. Using glulam elements or LVL elements, we can realize post and beam buildings. But nowadays, these two different typology are merged together, and we can simplify the system, obtaining post-beam panel system and post and platform system. Moreover, CLT building and post and beam building can be hybridized, obtaining post-tension timber system that are a very interesting construction technology. So CLT building is a box-like construction that is entirely realized assembling CLT panels by means of screw, brackets, and steel plates. So, of course, in this type of construction, the connection element play a crucial role, as you can from this imaging, where I port a general assembly of the system or a interstory node. So generally, the design of a multi-story timber building or better, multi-story CLT building are performed using numerical models. Of course, for gravity action, the analysis is simplified, and only a reliable definition of the boundary condition of each element is necessary. On the contrary, the analysis of the building subjected to horizontal action, such as wind or earthquake, require a correct calibration, or better, a correct implementation of the interaction between wall panel and connection system. So in this context, we can use two different modeling approach. The first one is a refined modeling approach named component level approach, and require the implementation of each structural elements in the model. And this type of modeling approach allow to capture both the global and local response of the system. On the opposite, we can use a simplified approach that is a phenomenological modeling approach that require the implementation and calibration of macro components, such as the response of the whole system. But this simplified modeling approach allows only to the definition the global response of the building. So it is important to highlight that sometimes this modeling approach is not correctly used, because only the deformability of the CLT panel is generally implemented, disregarding the deformative contribution of connection elements that is the predominant contribution in the lateral deformability of a building. So be careful about this issue. So the main check we have to do on the structural element are, of course, in plane and out of plane check of the wall, accounting also for the buckling phenomenon. Then for CLT floor, the main issue concerned with the vibration analysis. And for connection system, we have to verify all the connection that we have in the structural element. For example, the base connection, the corner connection, the interstory connection, and panel-to-panel connection. But the design have not only focused on the structural purpose, but also on the acoustic issue. In fact, the connection have to be integrated with some damper devices to reduce the acoustic problem. Then, mass timber construction are generally assembled using low or high capacity connection. But nowadays, some innovative high ductility connection can be used, and in this picture you can see some examples. So the ductility of the connection nowadays is a crucial issue, because the design of connection have to be based on the capacity design approach. So in this picture, you can see some brittle failure mode of connection. For example, this all down show a brittle failure of the steel plate. This angle bracket show a punching of the steel plate, and so on. So the design of the connection have to avoid the brittle failure. And it is worth noting that in timber connection, the ductile component is the fastening system, screw or nails, and not the steel plate or the base anchor. So to avoid this type of brittle failure, a capacity design model has to be applied. And in this picture, I've reported an advanced capacity design model that allow to verify this inequality, where, of course, the design strength of the brittle component have to be greater than design strength of the ductile component. But in this case, this strength is not the same we use for the static design of the system, but it is amplified by the over strength factor. Okay, so in this advanced model, the over strength factor can be calibrated on the target displacement. So we can define an over strength factor at the yielding condition, post yielding condition, or at the peak condition. So the value of this strength factor is very high. It is about 2 for standard or traditional connections, such as nails or bolts. More information can be found in this scientific paper. So now I give you a brief overview on other type of mass timber construction. So post and beam buildings that is really similar to concrete frame. So we can have one directional or two directional frame, and in this type of structure, the key component is the post and beam node that can be realized using different type of connection, such as a steel dowel connection, or in some special cases, also a connection with bars fixed with epoxy resin. So first simplification of post and beam technology is post and beam panel system, where the longitudinal frame is removed, and we have only transversal frame and a floor slab. So another simplification can be performed removing also the transversal frame, obtaining the post and platform system. In this case, we have only two components, the post and the floor. Of course, in this case, the structural grid is smaller respect to post and beam system, and an additional bracing system is necessary, such as a CLT core or external bracing system. So for this type of structure, the interstory joint is very important, since we have to solve two different problems, such as the problem of load perpendicular to grain and the punching of CLT. So in this picture, you can see an example of a valuable solution that will be presented in the next presentation. So now I give you some information about hybrid timber building that are generally realized to solve some limits of traditional mass timber buildings, such as vertical load-bearing capacity, lateral stability, or some issue related to robustness. So this is a first type of timber of hybrid system, that is a post-tensioned timber system. Here you can find two different types of this technology, the one developed in New Zealand and the second one developed at the University of Bologna. So the idea is to improve the stiffness and the strength of the wall by the post-compression technology. So, of course, the creep behavior of wood limit the applicability of this technology. The second type of hybrid system is the one that uses concrete, that can improve the local response of the floor by adding a concrete slab, but can also be used as a bracing system using as a concrete core. So in this case, the connection of the floor, CLT floor, to the core is a K node. So finally, I give you some information about the robustness of mass timber buildings. So I use directly on the issue related to timber structure, but it is interesting that in timber structure we can use both direct and indirect methods. Which is the differences between these two approaches? So in the direct method, we can compute the robustness of we can compute I think there is a problem with the audio. You can with
it's okay.
Yeah.
It's okay, Luca.
Okay, so using direct method, we can directly compute the robustness of the building, applying different approaches such as alternative load paths, segmentation, or direct design of some key elements. While in the indirect methods, we refer to conventional structural detail that allow to achieve a robust design of a building by means the use of ties or ensuring an adequate redundancy. So now I've reported in the next slide only some interesting aspect about mass timber buildings. So the first one is the fact that in mass timber buildings, walls can work as a deep beams, as you can see in this picture. And in this case, the ductility of the connection can help to activate some catenary or second order mechanism. So what's happened when the wall has some openings? So the design approach we can use is this one. So we can define an alternative load pack mechanism. And in the case of CLT, we can use a Virender truss resistant mechanism that can directly activate it when we have a monolithic wall panel. But when we have a segmented wall panel, we have to use a special connection system, such as the one you can find in this picture. So it is necessary to connect the different elements with the connection that exploit bending strength and shear strength. So finally, timber frame structure or post and beam structure behave as a concrete frame in case of damage of a pillar of a beam. So we have to consider that in general, timber is not ductile, but is a brittle material and show a limited post-elastic behavior. So timbers post and beam structure are characterized by a lower redistribution capacity and a lower catenary effect. So it is necessary to use ties in both directions and to design the floor as a membrane element. So in this example, I've tried to show you what's happened when we remove a base pillar. So you can see that in this case, a catenary effect is activated and a lateral bracing system is necessary to capture the horizontal action. So in the case the post and beam node is damaged, so this catenary effect cannot be activated. Therefore, the robustness of the building is ensured only by the membrane behavior on the floor. So again, the floor, when realized using solid panel, such as a CLT, have to be correctly designed, ensuring an adequate connection between the element, ensuring an adequate connection between the wall panel and the floor, and, for example, using a continuous air profile as bracket that allow to connect the wall to the floor, but also work as ties. So with these last details, I've concluded my presentation, and I would thank you for your attention.
Now it's time to our colleague Matteo Andreottola. Matteo is working in the headquarters in our technical department. He's a technical consultant for Rothoblaas. He graduated at the University of Trento with the thesis with the timber structure with the professor Maurizio Piazza. The design of timber structure has always been his passion and job after the end of the university. So with Matteo, we will see some detail. So we are going more in detail how to find the solution when we are designing and building mass timber, multi-story, and hybrid. Thanks, Matteo.
Thank you very much for the introduction. Let's go immediately to the presentation of today. So we'll see innovative connections for CLT structures. Let's have a look at what we're going to talk about in these presentations. We'll start with innovative brackets like Titan, for examples. Then we'll move on to the shear connectors for CLT panels, like, for example, the slot connector. And finally, spider and pillar that we've seen previously before. We'll have a better look at them more in detail, so that we have a better, so that we understand better how they work. So first of all, a brief introduction. Previously, nowadays, we're not only building private little structures with timber, but the market is moving towards very big multi-story structures, like the one you can see in the right side of the screen. And for example, Hoho Tower in Austria or Mjosa Tower in Norway are multi-story buildings which are more than 84, 85 meters tall. So that's thanks definitely to the more engineered material that we all know, like, for example, CLT or glulam or LVL. Definitely, the key thing, of course, the key thing becomes the connection. Really, the connection should have all the resistance. I mean, should have the resistance and as well the ductility to allow this massive timber constructions. As we've seen before in the previous slides, we have two kinds of timber structures. We have the heavy timber frame with bracings, with structural bracings, and as you see above, or we have structures with CLT panels. Talking about structures with CLT panels, the horizontal loads are brought down to the foundation by the connectors, of course, using two different approaches. There is the standard approach, which is the one that you can see on the left side. And basically, it works in the following way. You have hold downs placed at the extremities, at the ends of the wall and of the shear wall, and you have the shear connections in the middle, basically. We have innovative approaches as well, and the innovative approaches are the two on the right side. So with a connector that can withstand both the tension forces and the shear forces, or a solution like the X-rad solution, which is very, very innovative because you are concentrating all the connections in the nodes, basically in the corners, and so you need a connection which is very resistant, but at the same time very quick to assemble on site. Basically, how it works with the design of the structures, you're simplifying your complex structures in a series of shear walls. Of course, the shear walls have to be as much as possible continuous to the foundation, because as we said before, they have to bring down all the horizontal forces down to the foundations. And this is the first step, of course. You can decide to have different shear walls, like you can see here in the image. And so not considering basically the shear wall that you have in where the openings are. And so having in this situation, you'll have more hold downs, like all the red circles that you can see here. Or you can decide to have a continuous shear wall, and you have, of course, to verify your shear walls with the openings. Of course, these openings will need to be not too big in order to allow a verification of the shear wall. Of course, when we have a multi-story construction, the forces on the base connection will be very high, and I will show you some pictures here of 5 stories building, of a 9 stories building and a 5 stories building that were built in Rovereto, very, very close to the headquarters of Rothoblaas here in the north of Italy. And you can see how massive the connections to the ground are, especially these ones, are hold downs, and you can see, you can tell how big the forces are at the ground. So these are basically not standard connectors. Of course, as we said before, the timber is an amazing material because it has a very high resistance. It's beautiful, and also it is very lightweight, but at the same time it is a brittle material. So again, the key thing is the connection system. In the connection system, we have to concentrate all the ductility of our structure. You can see here in the slide here some of the tests to test the ductility of a structural connection and the cycles of load here in the diagram. Of course, you can see here in the picture some of what I mean with ductility, of course. These are some plastic hinges that formed into the connections. Of course, these plastic hinges can really dissipate the energy. So designing with such a way, it's very important, especially if you have seismic loads. But in every type of structures, it's very important to have a ductile link that can dissipate all of our energy, avoiding a brittle failure of our structure. Hopefully, at the end of the presentation, you'll know exactly how and where to use a lot of the connectors that we have previously seen. Let's start with some of the modern angle brackets. As we said before, these angle brackets can withstand both tension forces and shear forces. And let's see the example that you can see here on the left side. By adding this very simple steel plate just here on the bottom plate, you're increasing a lot the inertia of the plate itself by, of course, increasing the thickness of the plate. So just by adding this washer here, you help the connector withstanding as well the tension forces, because you can withstand the bending moment created by the eccentricity of this connection. This connection is very good because it can withstand forces in all directions, so that's a good thing. Another very similar connection is, for example, this Titan S. It is very similar to the one that we previously explained and seen. This one in particular, instead of having nails, it has screws, 8mm screws, so that you can have less connectors, and less connectors means be quicker on site, and so less installation time, which is very important when you have such big structures as the one that we've seen previously. And moreover, you can install these connectors without using hammers or automatic hammers, but just using a drill, it is possible to install these connectors. And of course, a drill makes less noise and, of course, less vibration, and can be quicker at the same time. So it is a much better type of connection. This one as well is a very engineered connection. It's a very simple, but at the same time very engineered, because as we understood from the previous connectors, the issue usually is the eccentricity that we have on these angle brackets. So just by placing these full threaded screws at the corner, we are basically reducing a lot the eccentricity of the connector itself, and so we don't have that bending moment that it's an issue for our connection. So as you can see here, the resistance of this connection is very high, up to 100 kilonewton characteristic resistance in tension, timber to timber. And we'll see some of the other advantages of these connections here in these pictures. So first of all, if you have a multi-story building and you have to change the thickness of your CLT panels from a floor to the other, you can use this type of connector anyway. So you don't need a through bar, and you don't need these two brackets to be aligned. Moreover, if you want to keep visible if you want to keep on site your beautiful CLT panel, you can just hide these connectors down under the finished floor level of your floor, of course. And so they are usually, as you all know, the hold downs are very tall, because of course they have to withstand the vertical forces. Just by engineering better the connector, it's possible to make it much smaller and hide it. Of course, all these connectors were tested to make sure that the ductility is there. Of course, in order to have a verification of the connection here, you would have a resistance domain, and you have to be inside the domain to get the verification that you need. It's all very simple. It's all in the catalog online, by the way, so you can download it, and all the resistances value are already there. Let's have a look at this other connection system. It's the slot connector, and let's introduce it with this small explanation. So if you have a big shear wall, of course, sometimes it's not possible to bring it to the construction site in one piece, of course, because sometimes you'd have issues, transporting it. So you have to cut it in smaller pieces. And think if you have really small pieces, you'd have to use so many connectors to restitch all the panels together. So a simple solution would be using this slot connector. So it's a connector that can withstand shear, of course. It has a very high resistance, because the concept is that instead of using a lot of nails or a lot of screws, which is of course another way of connecting the two panels, you're using less of these connectors here. You place them into a slot in timber. That's why the name, of course, and you place them together so that you're sure that they stay in place with two HPS screws, and the connection is done. So very fast. The resistance is very big, and of course these are connection that works very well with these big structures that need to be very quick on site and achieve very high resistances at the same time. So the other good thing, the other advantage, is that instead of having a lot of hold downs like you see on the left side, you'd have a very stiff shear wall that acts really as a single piece, and that's very good for the panel, of course, and for the resistance of the panel. This is the drawing that you can find as well on the website, and on the website and on the catalogs you can find as well all the resistances of these connectors, and they're all there for you. They depend basically on the thickness of the CLT and the layout of the CLT panel. Very easy to calculate, and so also the calculation part is very fast. As we saw before, it makes the process of building a CLT building even faster. And you can use it for wall panels or for floor panels or on the facades as well. So it's really up to the designer to use it wherever he wants, basically. Let's go immediately to the spiner connection. The spiner connection, you see some pictures of it before. It has all these arms, these steel arms that go in all directions. And let's see what the concept of the connector is. You all know these concrete structures, like the one you can see right now on my screen. They don't have the secondary structure at all. So basically, they have this continuous concrete slab on top. And the issue here is the punching shear in the concrete structure. So the concrete designers came up with this method to increase the resistance and avoid the punching shear in the structures. Starting, of course, from this concept, we've tried to do the same, and we've tried to see if it was possible to also in timber buildings, in timber structures, if it was possible to remove completely the secondary structure. That's, for example, an example. That's a continuous CLT slab, point supported by the columns, of course. And you can see another example. This is a famous building in Canada, just to show you how the finish would look like. Let's go more into detail and let's see how the spider works. You have basically the top load coming from the above column, and of course with the spider you solve the issue of the compression perpendicular to the grain. But at the same time, let's see what these steel arms Um, let's see how they work. Basically, you have the steel arm, of course, and this inclined full-threaded screws. And the aim of these full-threaded screws are, first of all, basically to hang all the floors and bring down all the forces back into this middle steel column in here, and then down to the bottom column again. And moreover, to the issue here with punching shear and timber is the rolling shear. Basically, punching shear means that you have rolling shear into the layers of the CLT panels, basically. So what these inclined screws do at the same time is to increase the resistance of the and avoid a failure for punching shear at the same time. So the resistance is very high. You see here the reinforcement for the punching shear, and as well the reinforcement for the compression perpendicular to the grain here. These reinforcement are not always needed because, as we said before, basically the floor is hanged onto these steel arms here that take all the load and bring it back to the other column. All the resistances are already calculated for you. So here again, it's very easy to calculate, even if it looks like a very complicated connection. You can find it on the catalog. And another advantage is that by having a continuous slab, you have the bending moment, which acts like the picture that you can see on the top right corner. So basically, the bending moment is not just as big because you have a continuous slab. Basically, you can see here the pieces that are part of this connection system. It's very important to use the right torque to install the screws, of course, because this is a steel to timber connection. So otherwise, it's the risk is to damage the screws, of course. And this is how you put together this connection. Is actually very easy, and you can use timber columns, or you can choose to have a hybrid structure and use, for example, as well, steel column or other materials as well, like alvoel, for example. In order to, of course, create a continuous slab, it is important as well to have this moment connection and create really this continuous slab. It is possible to do it by adding these steel plates into it and glue together the two floor panels with using CPOX, which is an epoxy resin, basically. That's just one way to do the floor. Otherwise, if you want to go for a more simple way, you could have this the CLT panels acting basically like a secondary structure, and the other panels laid down in the opposite direction, basically. So let's see what the advantages are. First of all, you save a lot of money and time because, of course, you don't have the secondary structure at all. So you need to use a lot less of meter cubes of timber. And as well, it's very easy to install all the installations here because they don't have to pass through the timber beams. That it's always an issue also to calculate, of course, if you have a hole in the middle of a timber beam. And of course, you have this nice architectural finish of the visual CLT that you can leave, of course, visual if you want. And most importantly as well, you are very quick because, of course, you don't have to do all the secondary connections of the secondary structure, and that's very important as well. So time saving is again crucial for this connector as well. Pinlar is very similar in a way to the connector that we've explained before. So it definitely solved the issue. It solves the issue of the compression perpendicular to the grain. And let's see how it works. So we've seen a picture already of this building before. It's Brock Common in Canada, in Vancouver. It was built in 2017. This building here doesn't use, in particular, the pillar connector. It's custom-made plate, but we can see we can see, for example, that the span between all the columns is not just as big as the one that you can achieve with the pillar. Of course, if you need to use pillar and you want to achieve the best, a really good acoustic behavior of the building, you can add an acoustic profile here as well. And you can use this connector here together with Spider. You can use, for example, Spider in the middle of the structure, and closer to the edges of your CLT floor, you can use this pillar connection, so that you use both of them together. These are all the pieces that creates the connection. And another important thing is the plate they can see here, this closure plate here. We'll see what's the aim of it in this picture here. So basically, all the forces they come down from the upper floor, from the upper column, and they all come down from this internal steel column, of course. And in order to avoid buckling, in order to make buckling less of an issue, it's installed with this closing plate on top here, so that the neat height of the column decreases a little bit, and you have a better behavior of the connection. In this case, you don't have the steel arms hanging the floors, so the floors are simply supported by, with simple bearing of the CLT panel down to onto the steel plate here, and all the forces, they go down onto the the columns, which is downstairs. Of course, you have reinforcement here as well, the full threaded screws, because of course compression perpendicular to grain could be an issue here. So you solve it by adding these reinforcements, and you have an uplift resistance at the same time. Again, here, all the resistances are already calculated for the engineers, and so it's very easy to calculate and to design with this product. It works just as well. You can do the same connections, the same bending moment resistant connections, and or you could avoid completely using the bending moment connections by just having the CLT panels on one span from a column to the other. Thank you very much for your attention. We finished just 3 minutes. We are almost on time, actually, so we have time now for some questions.
Yeah, so we've had a few interesting questions. A couple of people have asked about ductility and particularly seismic. So we've got M. Motok asking about the behavior Q factor in Q for post and platform, and about ductility classes. I presume that's the seismic ductility. You touched on that, Matteo. Do you have anything to ask or answer around that?
Yeah, of course, as we said before, ductility is very important, especially in if you need to have a seismic behavior of your structure. It's very important to say that when you use spider connectors or pillar connectors, these are all hinges, so they don't bring down horizontal forces. So in order to bring down horizontal forces, you need, again here, as we said before, a bracing system, and that's basically where the ductility is happening. So as a bracing system, you can use, for example, CLT panels or a hybrid structure with another type of material. So again, as we've seen before, you have to design your shear walls with the proper ductility, so that you can you have a good behavior of the structure.
Perfect, thank you. Definitely a topic that is a hot topic, excuse the pun, but definitely in the UK and particularly going around the world is fire. And Ben Newman at Arcadis has asked us about how does our resin perform in fire? I know that we've done some sort of preliminary fire tests with Z-Epox with threaded rods in the past. How do you think it interacts, or what's the best protection strategy with glued and Z-Epox connections in the floor slabs?
Is that a question for me again? Sorry.
I think so, Matteo. Yeah,
Fantastic.
I'm afraid.
Okay. No problem at all. So, of course, the behavior for fire is very important as well. Of course, we've done tests for the Z-Epox resin, and the behavior is very good. So, with high temperature, it doesn't melt or anything. It just burns at the same rate as you'd have the timber burning, basically. So, it is again, of course, important to protect it from fire at the same time, because you'd have the steel plate there. So of course you need to design your connections with the proper protection. The protection could be timber, of course, and so you'd have to design the CLT, for example, can be the protection, and you have to pay attention because the burn rate of CLT is slightly different from the one that you have on glulam, which is very, very easy to calculate, because of course you have the detaching of the layers of the CLT. Or you could use other methods, like for example a drywall, or plasterboard, fire-resistant plasterboard, or a lot of other products that Rothoblaas is as well, some of them, and of course the one that are mainly focused onto the connections are provided as well by Rothoblaas. So in the little gaps that you have between a structural element and the other, you can place fire-resistant products, so that you don't have the fire passing through, basically.
Beautiful.
Okay.
Should we take one more?
I don't know if you have time. Yeah, very, very quick. Then we need to close a bit.
We'll push one back over to Professor Luca. So Daniel's asking, what software do you use for mass timber design? And do you mix software using perhaps like the values in our tables in the design method? How do you approach that task?
Yes, I think that you can use every type of software for the design of timber structure. The key aspect is to adequately capture the interaction between the timber element. I think that this is the main issue. So the key aspect is to capture the deformability of the connection. Generally, for the design of timber structure, both under horizontal or vertical action, we can use equivalent static analysis. So nonlinear analysis are not necessary for the practical design of timber structure. Only when we perform analysis for example, for the robustness of the building. So in this case, if we want to do advanced analysis, we have to consider the nonlinear behavior of the system, and especially of the connection element. So in my opinion, all connection that we have in the building have to ensure a minimum level of activity. So because for example, also the spider, when we have to activate a catenary effect, have to behave in a tactile way. So it is important that all the connection have a tactile behavior. Then for the analysis, I have no software to suggest, because it's the input that are important, not the software.
Okay.
Beautiful. Thank you.
Thanks, Luca.
Thank you.
I don't think we have. Thanks, Peter. I don't think we have. Any more time. So I want to just say thanks to you guys, Peter, Matteo, and Luca, was very, very interesting. And thanks to all the people that join us from all over the world. And see you soon. Bye.
Bye bye.
Thank you very much.
Bye bye.
Bye bye.
Bye bye.